Hi, welcome back to this video series on formal verification of .NET code. In this segment, I'm going to formally verify the program called Max, which we discussed in the previous segment briefly. We inferred preconditions, but we didn't prove the program is doing what it's supposed to do. So let's first quickly infer the contracts and then prove its correctness, okay? The correctness of the Max function. So we have got some mistakes here, like array might be out of bound and things like that. So very quickly, we need to add these two contracts in our code. We can do that. So the users of the Max have to respect our contract that array they pass in should be not null. That's the first precondition. And the next precondition is that their array length must be at least 1, right? So those are the two basic things. Let's run it. Okay, I need to include the contract library from .NET, diagnostics.contracts. That should get us to the, okay, we got the validation 100%, no silly mistakes like array out of bounds and things like that, assuming the tool was verifying it correctly. What happens if I just now go and put a index like this, right? Hopefully the tool will tell us that we made a mistake. Yeah, very nice. It automatically gave us a constraint that we violated array access bound. Therefore, we need to make sure that this is not happening, right? So we get rid of this. And now let's do something more important. Verify whether the Max is actually doing the Max, right? There can be some mistake here, right? Still the Max verification will come across successful. Let's say I return Max -1. It says validated 100%, as you can see. Of course, this is not correct program. So we need to correct the mistake. So in order to do that, we need to introduce something called ensures, okay? That means you are guaranteeing to the users that the program will satisfy certain properties. What are the properties? The max value returned by this program is the maximum in the given array, which means it has to be greater than or equal to all the elements of the array, right? That's the first constraint. The next constraint is that the max value is coming from the array. It cannot be something out of the array, right? So the two constraints. So .NET allows us to specify these constraints in a compact way. We will use for all, and there exists notations. So for all, right? For all allows us to specify like this. For all I, we need this contract to be satisfied. Ensures that contract of result of int, right? What should this be? This each element of the array better be smaller than or equal to the result that we return from our code. That's the first constraint. Let's see whether we can compile this first. Okay, it seems there are no compilation errors, so let me keep going. To the next contract is that there exists, right? There exists an element I, index I, such that array of I becomes the result that we are returning to the caller of the max. So that's another condition we want the program to satisfy. Okay, let's give it a try now. Hopefully it validates and it says, yes, everything looks good. Let's make some mistakes now. Let's make a silly mistake first to start with. Let's put a less than here because sometimes people make a mistake like this. I have made many times. hopefully the tool will detect that we violated the contract. I'm running it online, right? You can actually run it in Visual Studio with, it should be much faster if you have a local installation of Visual Studio. Okay, so very nice. It says I'm unable to prove the contract for all contract that we said here between 0 inclusive and array length exclusive. Array of I is bounded by the result. Okay, this contract is violated. Very nice, because we made a mistake here. Remember, earlier it was greater than, I replaced it by less than. So our contract is actually working. Very nice. What happens if I just return 0 here, right? Well, it should be also a mistake. Or let me make it more interesting by returning the maximum value, right? What is the maximum value we have? The maximum value is basically int 32.max value, right? Hopefully, it should show that we violated the contract. I think we have violated the contract because naturally, yeah, you see here, we violated the contract that there exists an element of array which matches this result, right? But naturally, this is not true because we just simply send a maximum possible value. So our contracts are actually being used and our program is very correct. If we just do this way, we can be sure that there is no mistake. We use formal methods. This is basically mathematics and logic to verify precisely the code is doing what it's supposed to do. Of course, you need to be able to formalize this notion of what are you expecting the program to do, that using the ensures and requires conditions, then we can verify correctness. As I mentioned earlier, there are theoretical limitations due to halting problems in theory of computing, but many non-trivial programs can be verified mechanically. Okay, I hope you find this informative for your work. Feel free to contact me if there are questions. To summarize, all we did in this session is basically let the tool infer the requires contract for us, and then we added the ensures contract using for all and there exists, right? This is coming straight from the definition of max, right? This is how max should behave. And here is the little max. And we proved it for all possible input array. Doesn't matter how big the array is, how small the array is, this program will satisfy these two contract conditions. Okay, the verification is as good as your contract. What you can do is you don't have to put all the contracts at once, right? You can start incremental. You have one small contract, verify it, add more contracts and verify. You can incrementally grow your contracts as well. That's all. Thank you very much.